Right now, I think we should move on to the next talk. Dr. Thea Iberall is formerly of the University of Southern California. She's currently an award-winning author and poet. She's also the founder of one of the daughter of one of the founders of this field, Arthur Iberall. The title of her talk today will be Homeokinetics and Physics. Dr. Iberall.
Well, thank you so much. I need to have the screen, yes, to share.
And keep your video on as you share the screen.
Okay, great. I will be presenting from Arthur Iberall's writings. This first book in this list of his writings, and on the website there's almost 20 papers and books that he's written regarding social physics. But the first book in this collection is a collection of essays that I compiled after his death, which is a basic course on the physics, thermodynamics, and complex systems for doing homeokinetic applications. And it includes a homeokinetics primer. In this talk, I will describe homeokinetic physics, complex systems, and social physics. You know, yesterday Ram showed an elephant with everybody talking about different parts of the elephant, and I feel like I'm going to be talking about the elephant, which is an approach to complex systems based on physics. Arthur Iberall began observing a neglected area of physics, that of complex systems, which with their very long internal factory day delays. Iberall and Harry Sudak were able to turn keen observations into a new field of the physics of complex systems, and they called it homeokinetics, from the Greek meaning similar movement. This is in contrast to homeostasis, which defines stability arranged around a set point. In homeokinetics, stabilities emerge from interacting processes. Normal physics, or flatland physics, deals with the processes at single levels. Homeokinetic physics combines flatland physics with the study of the up-down processes that binds the levels. The approach models the entire universe as atomistic-like units bound in interactive ensembles that form systems level by level in a nested hierarchy. Today, tools such as mechanics, quantum field theory, and the laws of thermodynamics provide key relationships for the binding of the levels, how they connect, and how the energy flows up and down. Homeokinetics treats all complex systems on an equal footing, both animate and inanimate, providing them with a common viewpoint. The complexity in studying how they work is reduced by the emergence of common languages for all complex systems. As others have pointed out here, at least two scientists are needed, one who is versed in physics and irreversible thermodynamics, and the other is trained in the specialty. And that's why I put together the basics book. The first half of the book is for the specialist, and the second half is for the physicist. And there's a lot in there about the Navier-Stokes equations, which he says that he uses to extend this into all levels, including social physics. So where do we start? A person is a system bounded in time and space from above and below. Skin is the border separating the inside from the outside. The person's life is bounded in time from birth to death. When the person gets into a car, the person and the car become another system. The car joins other cars and lose their autonomy in traffic. The flow of cars in a traffic system is much like the flowing of blood cells through our veins. An atomism is a limited object of any size which is largely repeated in structure and character. It can withstand forces of interaction up to some level without permanently deforming, yet it can also bind with some of its counterparts. And it can possess and share mass, energy, momentum, and electric charge. A system is a group of relatively common atomisms organized into a higher ordered system is a group of relatively common atomisms organized into a higher order atomism bounded from above and below in the space and time domain. When the actors move, they interact with other actors. Two people see each other in a bar, they walk over, they talk, they perhaps dance together, which is how my parents met, by the way. Two cars avoid a collision by veering away from each other. The actors are engaged in a game which may be called banging into each other by pairs. Forces guarantee that the actors will bang into each other, and a few major things are conserved during this game, such as the sum of paired mass or matter, energy, momentum, and electric charge. In simple systems, when atomisms bang into each other after a few interactive collisions, they are brought into equilibrium. But for complex atomisms, their interior movements are organized into very, very long time delayed patterns as countable by external bangings, more like tens of thousands or millions or trillions. If you eat a cookie and you do not see the resulting action for hours, that's a complex system. If boy meets girl and they become engaged for a protracted period, that is complex. If a foreign leader tears up a treaty and a government takes days to respond, that is complex. The purpose of the action is to tell the story of the collective. For a group of molecules in a balloon, the story of the collective may be to form a gas. As a result of playing the game, by the sharing motion of their conservations, they all achieve the same temperature, or essentially the same energy. Now, if you want to face them, you'll have to face them as a collective. You're no longer dealing with single atomisms. How do you know that? Somebody can aim that balloon at someone else and blow them away. At a collective level, the story of the collective force is the social pressure. One can tell an army, a gang, or a group to go kill or go build a nation, and that bunch will walk out together and act no longer as individuals, but as a collective. Complex systems have very extended time scales among their atomistic processes. They have extensive field memory functions that spread out in time and space, and those are in physical, chemical nature. They use language. Languages are catalysts. Complex systems appear to direct their activities almost with purpose, and their interiors are complex factories involving complex factory day processes. The key homeokinetic problem is how the bottom collective structure and functions is connected to the functionally remote character at the top level. At the first rudimentary level, one takes a breath, then one takes another breath, and so on and so on. As long as breath follows breath and heartbeat follows heartbeat, some of the fundamental internal machinery is working. Note that the process starts out of the momentum and the movements of the heart, lungs, and other organs. At the bottom of this, there still remains only momentum, energy, matter, and electric charge. But let us move to a more integrative level. There's more to see over the day. The organism has searched for and acquired food, slept, moved, drunk fluids, voided, interpersonally interacted with its fellow organisms. There's much more machinery involved at this level, but notice, more or less, one day is like another. This is still not integrative enough. There are other machinery processes such as water balance over 3 days and the female menstruation cycle. But engraved within the body's machinery, there's more than a yearly scaling of processes. Let us imagine wandering around the inside of your body, or a city, or a civilization, or a galaxy. It will look like a giant busy play. All you will see are pieces moving in and out of a great number of stations. Activities and processes are continually going on. It isn't until a great number of steps have taken place at some or all the stations that what is going on is going to emerge as an apparent product or message. That you know that Act 1 of the play has taken place, or that an inning has been played. What emerges from the material energetic transformations are only such higher ordered products or messages that make up the same kind of material energetic processes we see in the simplest of systems. A transporting diffusion is added, a diffusion into internal action. That diffusion measure is called the associational or bulk viscosity. Here is where the long time delay lies, which makes for complexity. It is only a complex system if the complex patterns it displays repeat again and again and again. To study the complex system, our job is to recognize the repetitions and also recognize the conservations. Complex systems repeat their entire spectrum of performance over some characteristic period, referred to as their factory day, which is a period that is long compared to the time scale for atomistic interactions. You can't run a factory if every component of every level is constituted de novo. Instead, you have suppliers at various levels producing components at various levels, and it is that sort of upward and outward flow of materials, energies, and subunits of possible function which can run such a feasible homeokinetic universe of systems. Here is our atomism. There are internal processes at work, and we talked about those just before. The breathing and the 3-day water cycle. And the atomism is surviving, living in the Earth's environment that affords various driving potentials. And he talks about them as the solar flux, the Earth's atmospheric temperature potential, the physical chemical resources, and then of course the genetic potential on board. And since I'm an author, I extended that for the novel that I wrote, which includes a homeokinetic lecture in it, to be just some of the cycles that are happening at the planetary and solar system level that are all part of those driving potentials. But some of those are too high a level that really affect us. And there's a characteristic energy which is stored in the atomism. And there are fluxes of flows that potentials may drive, energy, materials. In a complex system, momentum is transformed into action, which is the energy-time product. So the flows are the flow of energy. An adult human needs about 2,000 kilocalories a day for that flow to not just survive, but to thrive. Much less than that would be really difficult. And then that's the characteristic energy would be across the whole factory day would be 2,000 kilocalories days per factory day. And then there's of course the flow of materials, eating that cookie, and so on, and the voiding. And then as he says, the instead of momentum, humans are in complex system, momentum is transformed into action, which is the energy time product. From cells banging into cells, we see their complex, slower biochemistry emerging. From that, we see organized actions throughout the organs. From thence, we see an organized actions of the organism. Each factory day or level has to be attended to by its physics, by its conservations. As one runs through the entire gamut of such factory days, one finds an entire cascade spectrum of energetic processes. Energy flows through, transforms level by level. So social physics, which he defines as the study of the physics of groups, colonies, settlements, political units, civilizations engaged in trade and war, as well as the history, development, and evolution of species, including the human. In order to study this, anything homeokinetically, he says choose your field of observation Concepts of science are reduced or replaced by operations necessary to measure them. And then learn all you can in all possible directions that you are free to explore in the inhomogeneity of levels and columnar chains seem to interact to produce forms. And it's in that where you can find it. So in order to study a social system, we start with the large social structures timescales. He's defined the 4-hour biophysical organization as the top scale for an individual person. That's the scale for chemical thermodynamic near equilibrium. And then there's other cycles that humans, social systems are part of. The day, Earth day cycle, which is a social regulation cycle, and then a week, and then a month, and then a 30, 60, 90 day cycle for seasons, depending on what kind of culture you have. And then the solar year basically is a corporate scale, 3 to 6 year command control for the political scale, 2 to 3 generations for life scale. And then he says that civilizations exist for about 500 years. So here's our collective level. And by working with anthropologists and economists, Iberall identified additional driving potentials and an additional flow variable. So at the social level, at some collective level, there are social cycles, as I just said. These are the little atomisms that are now in a collective. You know, you could think of this as a like a church that I belong to in terms of a complex system. Somebody put up a Black Lives Matter sign up. It took a few minutes to put that up. Our church has been studying that for the last 5 years and is about to make a comment on it. So it's that is a complex system, and coming into that collective, we definitely have social cycles. We have a flow of energy. Use about 52 kilo-BTUs per year. We have materials coming in. We have modes of action, such as you know, worshiping and studying signs and things. But there's also, in a collective, he adds a reproductive rate for a living collective, which makes up for the demographic flow. The population reproduction from its ancestors through its successors. And he shows that that's the birth and death rates cycle around near zero equilibrium. And then besides, he adds 2 more driving potentials. One is the technology rate potential, which is you know, that has improved our abilities over time to make, instead of just having the limited physical capability that we've had, has extended our capabilities. And a value system, which is, I think, kind of what was talked about yesterday, of how to incorporate these things, of like world images of self, nature, society, ritual, spiritual causality, art. And these are part of the driving potentials that he says, and he doesn't have a formalization of this other than to say that these are chemicals. It's a chemical level, and you can think of them as huge chemical companies that are in our society. And then at the at the higher level, at the political level, which to him is the highest level, and this is a superatomism level, he has added, so here we have our individuals with all of their flows and cycles, and then there's the whole collective with their flows and cycles, and now at the higher level we have the political cycle, the generation cycle, the civilization cycle. We still have to account for the flows of energy, materials, action modes, reproduction rate. Now he's added another flow called value and exchange. I think this is based on Carl Polanyi's exchange, value and exchange. He worked with Conrad Ahrensberg on this, and this is a way to capture all those money issues that that we were talking about yesterday in the whole political system. And you can see he calls this a superatomism. So it goes from atomism to collective to superatomism to collective all the way up. I need the last page. This is a chart that he created in the social physics primer. He and his colleagues presented this ladder ascent through the hierarchy of biosocial organization, making a series of platform stops in such traditional social science domains as primate ethology, hominid, tool-making, demographic development, linguistic evolution, cultural diffusion, economic exchange, political domination, legal evolution, and international conflict. Their objective was to show how, in a physical reductionist world, using only the principles of physics and nothing more, to construct a viable universe of hierarchically nested, self-regulating systems that include, inter alia, virtually all phenomena known to and perfectly explained by social scientists. The concept of hierarchical recursion holds that a predictable set of conservation-driven dynamical processes and design principles will be found to recur in nature at all mappable scales of atomistic and molecular associations, from the cosmos itself to the most minute leptons and quarks. The principle of hierarchical recursion is physically driven by homeokinetics, the observed tendency of all complex systems to seek essential stability, or autoregulatory immunity, against environmental vicissitudes and challenges through extensive internal thermodynamic coupling and cooperativity of such engine processes. Such self-regulatory cooperativity is found to occur both horizontally within individual organizational layers of a complex system, essentially as mechanical or chemical processes, and vertically between adjacent layers of a hierarchical system, essentially as thermodynamic processes. With that, I will stop. Thank you very much.
Thank you very much, Dr. Iberall. We have about 7 minutes. That's time for maybe at least one question.
Could I ask a question? One of your, this is Shyam Sundar, one of the slides, I think, mentioned something about being reductionist, but not in a vertical sense. Could you please elaborate on that?
Yes, I could. That's one of his quotes. He was reducing everything to physics, with the idea that you have your system that you're studying, and you're building next to it the physical processes that capture that element of the system. So it's the reduction is to a physical process, basically field processes. That's the complete reductionist idea.
Yes, so I would have thought that would be described as vertical reductionism. Why is it not vertical reductionism?
Well, he uses the word vertical reduction as chemistry is built out of physics, and biology is built out of chemistry, and up the scale. So that's the vertical hierarchy, up and down like that.
The reason I was confused was the quote denies that this is vertical reductionism, and yet it seems from the description that it is vertical reductionism.
No, because it's all physics. I mean, as the Aristotle quote says, that there's only one science, and that's physics. So it's a total reduction to physics. And he's basically using engineering physics as his main go-to. And I didn't talk about the thermodynamics because the thermodynamics is all in there, up and down through the between the levels, you know, and it's all addressed in terms of the flows, the potentials, and all that.
One question, Thea, is if your father believed that you and a person was an atomism, how does he fit life into the picture? Does he believe that the hydrogen atom is alive or not alive? And if not, where does life start in his model? Did he talk to you about that?
Maybe Bill Mace is here, can answer a question like that while I think about an answer.
Sure.
Well, he certainly believes the processes were continuous from the bottom up. I don't think he drew any clear distinction between life and non-life processes. So it's more of him is about looking at the continuity than the discontinuity. So to justify his studying, the ground floor of thermodynamics and just keep going up to each level that he addressed. So, I can't, he's got essays that would address that. He's addressed evolution. I can't pull it out of my head all right now, but you can find that, but I think his emphasis is a little more on the continuity. For example, another example would be language. If you look, for him, the important thing about language was its functional property as a very low energy coordinator. So for him, the key to language starts with a catalyst. And he says, a catalyst is the most fundamental set of principles that you need to understand language, by which I always understood he was looking at functions of language, obviously not structures of language.
Thank you.
And he looked at language at all these different levels. I mean, he says we talk to our organs, and there's language is a catalyst for in a chemical situation.